Hey, welcome everybody to lesson number 3, geometric sequences. So a geometric sequence is when the ratio between every consecutive term is the same. Basically, we're multiplying or dividing by the same amount every time. We talked about arithmetic last time. That was adding, subtracting. Now we're multiplying or dividing the same amount. So same idea. Except with multiplication and division, right? So we want to find a common ratio between each of these terms, right? Because there's some sort of ratio. So all we're going to do is take the very last number that they give us, divide it by the previous number, and we come up with the common ratio. And that needs to be the same throughout this whole problem, so we're just going to check. So we came up with 3 each time. That means our common ratio, we'll use R, it's going to be 3. So here's one for you to try. See if you can figure out what the common ratio is for this sequence. Remember, we want to start with our final term and work backwards. This gives me -1/2. So hopefully it's going to be the same thing throughout. So if I do -4 divided by 8, that's -1/2. And then 8 divided by -16, that's also -1/2. So you should have found your common ratio to be -1/2. Very similar problems below is asking if the sequence is geometric. So just as we noticed up here, we had to have the same thing throughout. So when we check these, we need to make sure that we have the same ratio throughout. So again, work backwards. 120 divided by 40, I come up with 3. When we do 40 divided by 20, this time I'm coming up with 2. So it's not consistent throughout. No, this is not a geometric sequence. Let's check out this one right here. 162 divided by 54, that ends up being 3. 54 divided by 18, that ends up being 3. 18 divided by 6, that also ends up being 3. So because we got the same common ratio every time, yes, this is geometric. Okay. By the way, I did those pretty quickly. I had a calculator sitting right here. I suggest for this particular set of problems that you get either Desmos on your phone. That's what I'm going to be working with. It's a really nice, easy, free program. Or if you happen to have one of the school calculators, a little bit more difficult to work with because of all the extra parentheses and such, but it'll still work. So make sure you have some sort of calculator with you because it's going to make your life way easier if you have that. Okay, so try out these few problems and resume the video when you're ready to check your solutions. Alright, so we're checking to see if these sequences are geometric. So we need to work backwards just like every other problem so far. We're going to do 9 divided by 36. That's going to reduce to 1/4. Then we're going to keep on going. 36 by 144. That reduces to 1/4. By the way, if you did this on the calculator, you would have had 0.25, right? But as long as we get the same amount every time, which we do, it's 1/4 every time, this happens to be geometric. When we check the next problem over, we're doing 1008 divided by 252, we get 4. Then when we do 252 divided by 84, this time we only get 3. We have a different ratio this time, so there's no way that can be geometric. Okay, so finding the ratio or checking the ratio is just a couple of quick division problems. Calculator helps out tremendously for those. Now we're getting into some more somewhat familiar territory. Just like arithmetic, we have an nth term formula. This formula is pretty easy to use, right? You need the first term, you need the ratio, and then we're going to be raising the ratio to the n-1 power. Okay, so this is what some of these problems will look like, right? We've got they want us to write the nth term of the geometric sequence, and the first example, they give us the first term as 3, our ratio is 6, and they want us to find the 10th term, right? The nth or 10th term. So we're in luck here because a lot of this stuff is actually given to us, right? If we're finding the 10th term, it requires the first term, which is 3, times the ratio, which is 6, times n-1, so this would be 10 minus 1. So we're talking here at 3 times 6 to the 9th power. And then again, if you're using a calculator like Desmos, you can really quickly, pretty easily type that in, right? 3 times 6 to the 9th. And then it tells us right here in the corner, 302.33088. 302.33088. Put the commas in the right place. And that's your solution. Okay, that's the 10th term of that particular geometric sequence. Let's check out another one. Right, this time they want us to find the 8th term if our first is 640 and our ratio is 1/2. Okay, so let's see. We're finding the 8th. 640 is our first term times 1/2 to the power of 8 minus 1. So really, that's 640 times 1/2 to the 7th power. Okay, again, using this Desmos calculator here, this is what we're going to be typing in. So 640 times parentheses 1/2 close parentheses to the power of 7. And it comes out to be 5. So our 8th term in this particular geometric sequence is going to be 5. You have a problem right here to try on your own, both A and B. I'll leave these up here as well as the formula for you to use. Pause the video and resume when you're ready to check. Alright, let's see how you did here. We're trying to find the 8th here, so let's see. We want the first term times our ratio to the 8 minus 1. So that's 16 times 3 to the 7th. That's what we'll type in. 16, times 3 to the 7th. Ends up being 34,992. That is our 8th term. Hopefully you got that one. This one, they want the 5th term. So we're doing 1,701 times 1/3 to the 5 minus 1. So it's 1,701 times 1/3 to the 4th power. That's what we'll type in. Clear that out. 1,701 times 1/3. Power of 4. And it comes out to be 21. Okay. Yeah, you could definitely do all of this without the calculator if you wanted to distribute and do all that with the fractions. That's fine if you wanted to, but we've got the technology to help us out, so why not use it, right? Next problem that we're looking at, they want us to write the formula for this geometric sequence, and they give us a sequence here: 6, 30, 150, 750, and then they want us to find the 12th term. So we're going to be doing a little bit of what we just did up here, except that we have to find some information first, like our common ratio. Right? So let's see. Our common ratio, if I was to take 750 and divide it by its previous term, we end up getting a common ratio of 5. So the formula, the nth term, requires our first term, which is 6, times ratio, which is 5, to the n minus 1 power. That's the formula. That's one of the things to look for. If we're doing the 12th term, we're doing 6 times 5 to the 12 minus 1. So 6 times 5 to the 11th power. That's easy enough to type in. 6 times 5 to the power of 11. Ooh, huge number. Here it is. It's 292,968,750. 292,968,750. That would be the 12th term of this particular geometric sequence. Okay, so really not that bad, right? You find your R value, plug it in into the formula, and then a little bit of calculator work. No big deal, right? Try this one out. Pause the video and resume when you're ready to check your solution. Alright, first, got to find that R value, right? 108 divided by 36, that ends up being 3. So our R value here is 3. So our formula, we use our first term, 4, times our ratio, which is 3, to the n minus 1 power. So you needed that formula. Hopefully you got that. Now we can start plugging in, right? We want the 16th. So that's going to be 4 times 3 to the 16 minus 1. In other words, 4 times 3 to the 15th. 4 times 3 power of 15. Okay, here's our answer. That's 5,700,395, 628. Not bad, right? Pretty easy to do. Pretty easy formula to work with. And again, if you're using a program like Desmos, or if you happen to be using one of the school calculators, hey, a lot of the work is pretty much just type in, right? Now we've got some problems that are giving us the second and 8th term, right? So it's not the first term, and it's not giving us something easy to find the ratio. So we're going to have to do a little bit more work here. But they do tell us the second and 8th terms are 24 and 98,304 respectively, meaning this is the second term and this is the 8th term. They want us to find the 11th term. So what we need to do is, first of all, we need to figure out how many numbers are in between what they gave us, right? Our n would be the difference between the 8 and the second. So there are 6 terms between these two. Okay. Now let's think about what's going on here, right? A sub 8, our 8th term. Because we're multiplying with a geometric sequence, we know that we can actually take whatever our second term happens to be, and if we multiply it by our ratio, it's going to end up being the difference between these two terms, which we found to be 6. That's how many ratios there are in between these two. So we were able to use a little bit of backwards thinking, right? The 8th term is the same as the second times whatever that ratio happens to be, with a difference of 6. Okay. Once we start plugging in numbers here, 98304 and 24 r to the 6th. We can start solving, right? Divide by 24. That gives us r to the 6th power equal to, let's see, 98304 divided by 24. That's 4096. Now, we need to get rid of that 6th power. So we need to take the 6th root. That's going to get rid of the 6th power for us, giving us r. But now we've got to figure out what that value is. So I'm going to go over here on the calculator, functions, miscellaneous, and then you'll see that there's like this little square root with an n here. I'm going to press that. It's now giving me the option to pick whatever index. So I'm going to put a 6 up here. I'm going to go inside 4096. And the 6th root of 4096 is 4. So that's our R value. Now we're going to use the same idea that we did over here, right, to figure out what R was. We're finding the 11th term. That's equal to the 8th term, whatever that happens to be, which we know, in fact, times the ratio to the difference of these power, right? 11 minus 8. So we're going to end up plugging in the few things that we know, right? We know this is 98304. We just found our ratio to be 4, and 11 minus 8 is 3rd power. So this is a shortcut at this point that we can type right in. 98304 times 4 to the 3rd power, and it's coming up with 6291456. So, just so that we're clear with what's going on, the fact that we have a geometric, which is multiplication, we know that it's going to be multiplying the same amount over and over. So we took the idea of whatever the two terms they gave us, we know that we're using that many ratios more of the lower, right? The smaller number that they give us. So that's how we end up finding whatever that ratio was, right? We plugged in what they gave us, using the difference between them for that ratio. But then we repeated that same idea with whatever one we're trying to find and the closest one to it. Right? So the difference between these two particular numbers would be how many ratios we are using. We found that ratio and we already knew one of them. So it's it makes sense what we're doing here. Okay, you've got one to try on your own. We'll leave this work up here for you to use as a reference, but pause the video and resume when you're ready to check this one. Alright, let's check this out. So we need to know how many times that we're multiplying in between these numbers, right? We end up finding that there are 4 repetitions that we're doing here, right? Meaning the 7th term is equal to the 3rd term times whatever ratio to the 4th power. We're using that ratio 4 times between these. If we start plugging in some values here, we can start solving, right? We've got to divide by 147 on both sides. So r to the 4th power, let's see, 352, 947 divided by 147, that's 2,401. And then again, we're going to have to take the 4th root. So let's see, on the calculator, we've got to go to functions, nth root there to give us the index. So 42401. Our root here would be 7. So r is 7. So far, hopefully, that's what you're coming up with. Now we want to find the 10th term. We know the 10th term is the same as the 7th term times r to the 10 minus 7, right? The difference between these is how many of those ratios we're using. We know 352, 947 for A7. R we just found to be the 7th, and then 10 minus 7 here would be to the 3rd. So if we type all that into the calculator, 352, 947 times 7 to the 3rd power. That's what it looks like on the calculator. Typed in, and that's our solution. That's 121, 403, 821. So far, geometric sequences actually pretty easy. The formula for it is not bad at all, and it makes sense with doing some of these types of problems. What we're going to look at next, and we're actually almost done here, is finite geometric series sum formula. Whoa, that's kind of a mouthful, right? So basically, if we have so many terms of a geometric sequence that we want to add together, this is the formula that we would use. It tells us that we need the first term, and then we're going to multiply by this weird fraction, which is 1 minus ratio n power divided by 1 minus r. So as long as we have a few of these things, it's just basically another plug-in, let the calculator do most of the work for you type problem, right? So let's check it out. The way that this is written up here, they give us what number we're going to, so that's our n is going to be 8. The way that this is also written is this is our r, right? This would be a1 times r to the power of n. So this is our r. And then finally, we have our first term, which is going to be 5 times 0.6 to the first. So it's really just 5 times 0.6, which is 3. Okay, you can check that on the calculator if you need to. Right? So we now have the few things that we need here. We're trying to find the 8th term. So we need the first term, which we found to be 3, times 1 minus r, 0.6, to the n, which is 8, divided by 1 minus 0.6. So I'm going to type this all into the calculator. And I'll show you right here. Okay, 3. I'm going to need double parentheses, 1 parentheses for this top piece, 1 minus 0.6 to the 8th. So that's the top, divided by 1 minus 0.6 for the bottom. And there we go. There's the answer right here. That's a lot of decimals. It doesn't tell us what to round to, so why don't we just do a couple of decimals here? Right? It's telling me 7.374. That's not bad. I mean, there's a couple more digits after here that we could add on if we wanted to. It doesn't say exactly what to round to, so that's fine. Okay. Pretty easy. Here's one for you to try. Really, you're just using that pretty basic formula, and if you have decimals or a calculator to type it in, pretty easy. Pause the video and try this one out on your own. Alright, let's check this out. We know our n, our number we're going to, is 13. The r they give us here is 0.2. And if we want to know our first term, we have to actually calculate that. 18 times 0.2, that ends up being 3.6. So we have the three things that we need for that formula, right? S sub 13. That's going to be our first term, 3.6 times 1 minus the r to the n power divided by 1 minus r. So that is what I'm going to type into the calculator. Right? These are nice calculator problems. Sure, I guess you could technically do this all by hand, but I don't know why you would want to. Okay, that's my top piece right here, and now I have to divide it by 1 minus 0.2, and here's our answer. Again, it doesn't tell us what to round up to, so we're just going to write a couple of digits of this. 4.499999. Let's see. Looks like there's 7 of those. A couple more. 631. Depending on if you decide you want it to round, you know, if you round, a lot of these are going to round up, so it's going to look like pretty close to 4.5. Or if you want it to be as precise as possible, all the digits. Didn't tell us what to round to, so depending on what you did, you should be around somewhere around 4.5. Okay. Here, something different. This is kind of weird the way that this is written, right? It says the absolute value of the ratio has to be less than 1. So basically, if our ratio is in between 0 and 1, so a decimal or a fraction less than 1, we can take an infinite number of geometric series and add them together, right? Just like the arithmetic infinite series, we can do it with geometric too. But there's a limitation on this. It's telling us that we have to have an r that's a fraction less than 1 greater than 0, okay? Or the absolute value would be. And if that's the case, we just take our first term and divide it by 1 over r. I could show you the exact reason why. It has to do with the fact that r is approaching infinity after, or I'm sorry, n is approaching infinity after a while in that other formula. But let's just trust this formula for right now. Okay? So, this is our problem that they give us, right? We're going up to infinity. This is 0.25. It doesn't look like it, but that's a decimal right here. So that's 0.25. Okay, so we do have an r, and our r happens to be less than 1. So because this is true, we can actually just use this formula right here. We got to find the a1 value first. So that's 4 times 0.25. That ends up being 1. And then this formula is pretty simple, right? It's 1 divided by 1 minus r. You type that into your calculator, and it ends up telling you 1.3 repeated. So we'll write a couple of these. Okay, pretty easy to do problems, right? It's a quick little fraction, easy to type into a calculator. Let's take a look at this one right here. This time they give us r as 3.4. That's a problem because 3.4 is not less than 1. So not only is our ratio not less than 1, but according to this, it's not even going to give us any kind of sum. A sum's not possible. Easy enough. Okay, so you have the last problems on this video to try out right here. If possible, you want to find the sum. Here are your problems. Pause the video and resume it when you're ready to check. Alright, so you should have noticed that your r value here, 1.4, is greater than 1, which means that there's no sum possible for the first one. Right, we can't have an r value greater than 1. The absolute value can't be greater than 1. So this didn't work. But on this one, we can see our r value 0.7 is less than 1, so this is going to work. And the formula is pretty basic, right? We need to figure out what A1 is. So we got to do 16 times 0.7. If you type that into your calculator, you end up getting 11.2. So I need that number, right? The formula here is A1, which is 11.2, divided by 1 minus R, so 0.7. So in other words, 11.2 divided by 0.3. I can type that in real quick. 11.2 divided by 0.3, and that ends up being 37.3 repeating. Did you get those answers too? I bet you did. This is pretty easy stuff, right? Formulas, calculator, regardless what kind of calculator you're using, if it's a nice graphing calculator like the one that we've been using, either here, Desmos, or the TIs at school, stuff is pretty easy, right? Just plug and chug. So anyways, if you have any questions that you want to ask for the internet world out there, maybe they can answer it for you, or bring the question into class would be easier for me to answer. If not, I guess I'll see you at the next lesson for this unit. Hey, we're almost there, guys. We're almost there. See ya.